Students, now we are going to see next unit number 4, where we are going to discuss the topic development of surfaces. It is a completely practical oriented topic where we are going to see the sheet metal work. You could have done some exercises in EPL lab, engineering practices lab, where you could have done a funnel, tray, or some other object using sheet metal. So that process we are going to see here. So this is the prior skill set you require to learn this topic. One is first angle projection. You know what is first angle projection. Lines and its types. So far we have discussed so many types of lines where the each line has its meaning, right? So that is very important to apply here. Projection of plane surfaces, projections of planes. This is another topic we have discussed earlier, and that knowledge is required here. Projections of solids. In earlier unit, we have discussed the projections of solids, so that is also required here because we are going to deal with projections of solids only. The sections of solid. So sectioning is nothing but cutting the solid. So that knowledge is essential here. So this sectioning is done using the projections of plane surfaces only. So plane here applied as sectioning knife. So that we are going to see here. So we are using all along, all dimensions are in mm. Don't miss to write this with your problem. So all dimensions are in mm. Development of surfaces. To define the development of surface of an object is the unrolling or unfolding of all surfaces of an object on a plane. So we are unfolding an object and we are keeping on a plane surface and we are projecting it. So that is the development of surface, and otherwise it can be defined in these words also. If the surface of a solid is laid out on a plane surface, it is plane surface. It is nothing but the planar surface. The shape thus obtained is called the development of that solid. So this is also another definition where this also gives the same meaning like this first definition. So principle of development, it is very important. Please keep this in mind while doing the development. This this point is very important. We have to stick on to this point and we have to do the problem. We have to solve the problem. Every line on the development should show the true length. So we are going to deal with the true lengths only. No need to take any apparent length or some other length, only true length. Where we can see the true length, only there we have to measure and draw on the drawing sheet. True length. So please underline this and keep this in mind of the corresponding line on the surface which is developed. So at some cases we might be observing only apparent length. In that case we need to find the true length and we have to draw using that length only, true length only. So don't miss to draw these true length lines. So always you have to use true lengths. Applications of development of surfaces, there are enormous number and few I have listed here. Sheet metal work, marine and automotive bodybuilding, construction of storage vessels, even the construction which is used in our day-to-day life, the household articles like kitchen vessels, right? So computer and electronic casings, boilers, chimneys, and etc. So there are many applications of development of surfaces. Methods of development, there are few four methods and we will see them. One is parallel line development or stretch out line method. So this method is particularly applied to prism and cylinder. Radial line development, so this particular method is applied only for these objects like pyramid and cone. Triangulation method, so triangulation method is applied for the objects with which is made up of transition pieces. And approximate development, so it is normally used for building a sphere, paraboloid, ellipsoid, hyperboloid, and helicoid. So these are the few objects which can be made using approximate method. So these are the four methods of development. In our syllabus, we are going to discuss only parallel line development and radial line development, only these two, and we are not going to touch these two, triangulation development and approximate development. These two are little advanced topics for our syllabus. These two are not required. Parallel line development, where this is the prism, right, and this is the front view of the prism, and this is the top view of the prism. So we are just opening this, right, unfolding this on a plane surface using parallel line development. So actually we have to draw the lines, parallel lines, and this should be drawn along that parallel line. So this is the unfolded object, and you can see the top and bottom base, and these two are stretch out lines or parallel lines, and these are known as seam line where we are going to join it, and this is the first seam line, and this is the last seam line. So both can be what you called joined together to form this object. It is a pentagonal prism. So radial line method, it is hexagonal pyramid. So pyramid and cone can be developed using radial line method. So here with this is the true length, right? So this is the slant edge which is parallel to VP. Obviously this will give you the true length, and using that length as radius, so we can draw this arc, and we can cut the face. So this is the base side. So using that base side we can cut, and 6 number at 6 places, and we can complete this development. So these are the 4 lines, slant edges, and this is the joining line, that is known as seam line, and this becomes our vertex. So this is radial line development. We will see the procedure, step by step procedure. Triangulation method, so this is triangulation method, and this object can be built, right, using this many number of transition pieces, and this is the seam line, and this is the folding line. And approximate method, so these are the looms. So these are known as looms. Number of looms you can construct, and you can build a sphere like this. So these are the number of looms required to build a sphere, and this can be developed, and this can be unfolded and can be shown like this. So this each one is known as a loom. And steps in development of solid, these are simple steps I have devised. You can see this is a pentagonal prism. So we can take any one face, right, lateral face can be our reference. With that we can open the solid, and I have taken this face. I can name this, right. So this is C1, D1 and D, and this is considered as my reference face. And from here I can unfold this C1, B1, CB face first, and this side I can unfold D1, E1 and DE. So this face can be unfolded. So next I can spread this face, right, and I can complete this development. Right, so first I have unfolded the first face which is attached to this reference face, and then this side also I have opened it, and now the left out face is this, right, and this is unfolded in this direction, and this side we have one more face that should be unfolded in this direction. So this is the direction of unfolding. So no need to draw this arrows and all. and if you unfold this and keep on the plane surface, and that gives you the complete development. Now to develop this, I need to develop its base also, right? And we have top face and bottom face, so both can be developed like this. And this is C1, and B1 is sitting here, and A1 comes here, right? And E1 comes here, right? So this is D1. So remaining parts, the remaining points can be projected like this. And similarly for bottom also we can develop, and you can see the corresponding points. So this is the complete development. So in complete development, we have to develop its top and bottom surface also. So possible cases in development of solids: one is lateral surface development, another one is complete development. So in lateral surface development, we can exclude the top base and bottom base, we can exclude, whereas in complete development we have to include them, right? We have to include top and base of vertical solid. So these are the two possible cases. Development of simple solids, and this is the cylinder should be developed using parallel line method. So this is parallel line method, and a cylinder can be spread out using its perimeter pi d. So calculate it and draw two parallel lines. So draw this rectangle, and top base and the bottom base can be developed like this. So cube, it is a prism, it is a type of prism. So this can be developed like this. So you have four lateral faces, and top and bottom faces should be developed. Tetrahedron, it is made up of equilateral triangles, and you can just open like this and show. Prism, number of rectangles, right? You will be having, suppose if it is pentagonal prism, you will be having 5 lateral faces. Similarly, you can fix number of faces depending on its base shape. So this is h height of this prism, and this is side. Using side we can develop this, and this is complete development. Cone, you have to do a small exercise, a small formula, capital R by L into 360. So subtended angle should be measured or calculated, and it should be done like this: R of base circle, that is the radius of base, divided by true slant length. So this slant length, don't take the height. So height, if you take, you will not get the correct development. So you have to take only slant length into 360 degree. That gives you subtended angle, and measure it, and with that angle draw the arc, and you can complete the development. So L is nothing but slant length. So radius is L, and this is your base. Base is obviously a circle. So using this theta R by L into 360, that theta should be drawn between these two radial lines, and that should be measured between these two radial lines. So this is the procedure for cone development. Pyramids, number of triangles, and then base, how many sides you have. Depending on that, you will have the complete number of faces, number of slant faces. So here it is a square pyramid, so you will have 4 slant faces. So it is also very simple, and you can draw an arc, right? No need to measure any theta, and using side length, right, from one end you can cut arcs, and you can complete this development. It is again a simple procedure. So problem number 1 is a rectangular prism of cross section 45 by 30 and a height 55 mm rests on the ground on one of its ends, with one of its longer edges of the base inclined at 30 degrees to VP. So here the longer edge of the base is inclined at 30 degrees to VP. So with this point we have to draw the orientation of true shape. It is cut by a perpendicular plane perpendicular to VP and inclined at 30 degrees to HP. The cutting plane meets the axis at a point 45 mm above the base. Draw the development of the surface of the lower part of the prism. So here only lower part includes the bottom base also, right? So the lower part should be developed here, so that should be noted down. And it is a rectangular prism, and the orientation should be drawn in such a way that it is making one of its base edges is making 30 degrees to VP, right? So with that orientation we have to draw, and we have to cut the plane, cut the solid right at 45 mm above the base, and that plane is inclined at 30 degrees to HP. So with this information we have to proceed in this problem, a very simple problem. So first draw XY reference line, and at 30 degrees, right, you draw a line. So on this line you draw the rectangle of the given side, so that is 30 mm and another side is 45 mm. So longer edge is making 30 degrees to VP, and height is 55 mm, and draw the rectangle front view. So this is the front view of this prism. So this is the front view. So you know how to draw this front view, right? So this is A dash, D dash, B dash and C dash, and 4 edges, right? I have named only one side since I am interested to develop only the cutting points. So those cutting points I am going to develop here. So another side I am not giving any names, so that way also you can proceed, right? So here this is 45 mm on axis, on axis the cutting plane passes through this point, right? So 45 mm from base, right, 45 mm from base, and this cutting plane is inclined at 30 degrees to HP, and this is the cutting plane representation. Through solid draw the thick line, and then axis line. At the ends you draw thick line and show the arrowhead like this, and this is my first cutting point. So first cutting point I am obtaining on A vertical edge, and the second cutting point I am just notating in order, in this order only. So on B edge I am going to obtain point number 2. So this is 2 dash, and on C, right, so on it is not cutting C, so but it is cutting the top surface, right? So you have two edges here, one is CD and also CB, so it is cutting both CB and CD, so it is 3 and 4, right? So one is CD, another one is CB. So here within bracket I have kept 4. So the bracket point, right, the point which is in bracket is actually situated on C and D, right? So that cannot be seen. So that's why I have kept within bracket, and 3 is on CB. 3 is on CB. So this is my 3 and this is my 4, right? And my fifth point is on D, right? My fifth point is on D. So I have totally 5 points. I have to project them on to my development also, right? So now with the thin lines from each and every point, right, you draw thin lines. So these are known as parallel lines. That is why it is the method is known as parallel line development. And now you take some sufficient distance from this view, and that the development that you are going to draw here, you can start somewhere, right? You take some appropriate distance, convenient distance, and start the development. And I am taking the little distance here. So this is A, right? A should be drawn, A should be written in capital letter only, in capital letter only. So now from here, right, draw only thin lines, don't draw any thick lines right now. This is 1, this is A. From A to B, right, it is 45 mm. So from A to B measure 45 mm, and draw B line. So from B to C it is 30 mm. So from B to C take 30 mm and draw C line. From C to D it is again 45 mm, draw at 45 mm, right? So from D to A again it is 30 mm, draw a line at 30 mm. So this is the this is the lateral development, right, of simple solid. So we have to mark the cutting points also. So the base is obviously a thick line. We are not cutting anything here. The lower portion is this much, right? The lower portion is this much. And now this is A, right? A, and my first point is on A, right? So I will be getting this first point here. So point number 1 is located here. So 1 here as well as here. So 2 is on B, so I have 2 here, right? So 3 is here, right? 3 is here, 3 is in between C and D, C and B. So B towards C, I have 3. So measure from B to 3 this distance. So remember, you have to take only true length, right? So true length to draw this B to 3 is obtained in top view only. So measure this distance B to 3, and from B to 3 you mark the distance. So that becomes point number 3. So similarly C towards D you have 4. So true length can be measured only here in top view. So C to 4 you measure and mark here. C to 4, right? C to D, and mark 4 in between C and D with this distance after measuring here, right? So this is 4, and 5 is no problem. I can easily get here. This is the intersecting point and this is my 5. So I have obtained all the points, right? So I have to draw thick lines. So A to 1, right? 1 to 2, right, and B to 2 also thick line, and you have C is complete line, it is a thick line, and D to 5 thick line, and A to 1 thick line. Now 1 to 2 should be thick line, 2 to 3 also should be thick line, 3 to 4 it should be thick line, and you have a fold here, and you continue up to 4. 4 to 5 should be thick line, and 5 to 1 should be thick line. So this is the lateral surface development, but we need to develop the lower part of the solid. So this is the lower part and this is the removed part, and this can be called as retained part also, right? So we need to draw this, and now this is 4, right? This is 4 and this is 3, and you measure this 3 to 4, right? 3 to 4, right? Sorry, this point that is C to 4, right? C to 4, and now draw a thin line here, thick line here, right? Draw a thick line here, right? So this is thick line, and this distance is nothing but from C to 4. This distance I am using because this will sit, right? If I fold, this will come and sit here, right? So that way you can take this, and this is 3. From 3 you can draw a thick line straight away. So if I fold it, this point will come and sit here. So this will become my 4, right? This is my 4. So I have to take only this distance to project this 4 here. So this is the top portion, and bottom you can draw the rectangle anywhere you want, right? Anywhere you want, but if I draw here it will look very nice, right? So draw the rectangle here, so this is A, right? And this will become C, and this will become D, right? So that way you can give names, right? You can give names. So that is the retained portion development, that is the lower portion development. And we will see one more problem. Problem number 3, right? A pentagonal prism of base side 30 mm and axis length 60 mm is resting on HP on its base with a side of base parallel to VP. So one side is parallel to VP, that is the orientation given. It is cut by a plane inclined at 35 degrees to HP and perpendicular to VP, and meets the axis at a distance of 35 mm from the base. Draw the development of lower portion of the prism. So here also it is lower portion of the prism, and it is also very similar problem like earlier problem. We will see step by step. And this is pentagonal prism. The one base, right, one face, right, one lateral face is parallel to VP, or one base edge is parallel to VP, and with the given height you can draw the pentagon, right, pentagonal front view. So now it is cut by a plane, right, it is at 35 mm from base, and it is making 35 degrees to HP. And similarly view points. So here it is cutting all the lateral edges, right, all lateral edges are cut here. So this is my 1, and 2 is on B, and 3 is on C, 4 is on D, and 5 is on E. So there is no problem, you can easily develop it, right. So now draw parallel lines, right, draw parallel lines. So here this A to A, and all sides are 30 mm only. You can divide, you can draw 35 mm line, 30 mm lines at 30 mm distances, right. So this is point number 1 on A, point number 2 on B, point number 3 on C, point number 4 on D, right, point number 5 on E, and 1 is the again starting point. So now we can draw the thick lines. We can draw thick lines. So base should be drawn with thick line. So it is also very similar to earlier problem, and now we have to develop its base also. Base is obviously a pentagon. Anywhere you can draw the pentagon. Normally in middle, if you do it, it will look very nice. And draw the pentagon and give notations. So this is C, and this will become B, A, E, and D, right. So E is coming here, A is coming here, B is sitting here, right. So you can name accordingly. So this is the lower portion or retained portion development of this pentagonal prism. So problem number 4, it is a cylinder of base diameter 50 mm and axis length 65 mm resting on HP. On its base it is cut by a plane inclined at 60 degrees to HP and perpendicular to VP. The cutting plane passes through a point on the axis at a distance of 25 mm from the top end, right. So it is given 25 mm from top end. Draw the development of the lateral surface of the right portion of the cylinder. So right portion we have to concentrate, and lateral surface development we have to do here. So this is the cone. Draw a simple front view and simple top view. So I am dividing this into 12 equal parts as usual, and I am naming it A, B, C, D up to L. And the front view is obviously a rectangle, right. So here students, don't draw thick lines. These are generators only. So these generators should be drawn with thin lines. Don't ever draw thick lines, right. So at 60 degrees, right, at 25 mm from base, right, from top base, right, the cutting plane passes through this axis at 60 degrees, right, 60 degrees. So this is the left portion and this is the right portion. So we need to develop only this much, right. So here this is cutting base. So this is the cutting point where you have two cutting points. So this is A towards L and A towards B. You have two cutting points. So this is one, and it is cutting this edges B and L, and on B it is 2, right. On C I am marking 3, on D I am marking 4, on E I am marking 5, and it is cutting the top base, right. So in between here, right, in between H and J and F and E, right. So those 2 points I am getting here. So this is the F and E. In between F and E I have a point, so that is a visible point, so that will be sixth point. So from H towards I have one invisible point, so that is seventh point within brackets, right? So now on I have eighth point, and on J I have ninth point, on K I have 10th point, and on L I have 11th point, and here in between A and L I have a point, so that is 12th point. 12th point. So those points I am marking here. So this is 1 and this is 12, and this is 6 and this is 7. These two are on top and bottom bases, these 4 points, and remaining points as usual you can mark on the edges. Remaining points you can mark on the edges. So these 4 points I have marked here to measure the true length, here, right? So now you have to stretch it out using pi d formula, right? So this is pi d, you measure it, right? You calculate it and draw here how much this is pi d, pi into 50, right? You measure and mark, and now divide this into 12 equal parts, right, using dividing line method, right? After dividing this into 12 equal parts, right, now you can project these points. So this is 1 is here, A towards B you measure with compass, right? You measure with compass, and from A towards B you mark that point, right? You mark that point. So this is 1, and 2 is no problem. 2 and 11 I can obtain on a single projector, and 3 and 10 I can obtain on single projector. 4 and 9 can be obtained on single projector, right? And you have 5 and 8, even that can be obtained on single projector. Now I have 6 and 7 points. So similarly I have to measure either from H towards I, right, or I can measure F towards E, right? Anyway I can measure, it will be same distance, right? It will be same distance. So 6 and 7 I am obtaining here, right? And right portion development we have to do, right portion development, and this is the right portion development, right? This is the right portion development. So this is the right lateral surface of right portion. So this is the lateral surface development. No need to develop its top bases, right? Top base or bottom base. So actually if it is not given lateral surface, then we have to develop only this much portion also. So this much portion we have to develop, whereas here nothing is mentioned. Draw the development of lateral surface, only lateral surface. So that is the vertical surface development is enough. So this is the development of right portion lateral surface development. Next we will see another problem number 8. A regular pentagonal pyramid of side 40 mm and altitude 75 mm has its base on HP with a side of base perpendicular to VP. The pyramid is cut by a section plane perpendicular to VP and inclined at 30 degrees to HP. The cutting plane meets the axis of the pyramid at a point 30 mm below the vertex. Obtain the development of remaining part of the pyramid. So here remaining portion should be developed. It is a pyramid problem, and here it is a pentagonal pyramid, and first we have to draw the simple front view and top view. So this is the pentagonal pyramid. The orientation is given. The one of its base side is perpendicular to VP, and here this is the simple front view, right? This is the simple front view, and draw the cutting plane. You have to cut the plane, right, at 30 mm from vertex, right, at 30 degrees. It is passing through 30 degrees. Now this is an inclined plane, right? Now this is 1, this is A. On OA you have 1, on OB you have 2, right? On OC you have 3, and OD you have 4, so 4 should be within brackets. And you have OE, right? You have point number 5, so that should be within brackets. So these are the points, you are obtaining 5 points, 5 edges, and you have 5 points. Now these points it should be projected onto our development. So here students, you should be very careful, right? As per the principle of development statement, we have to take only the true length, right? So which is the true length line? So this is not a true length line, this is also not a true length line, only OC is the true length line, since OC is the slant edge which is parallel to VP, right? Only this slant edge will give you the true length. So all the points should be projected onto true length line, right? 2 4 should be projected onto true length line, 1 5 should be projected onto true length line. You have to measure the true length along this OE line, right? For all the points you have to measure on OE line, that gives you true length. So using that true length you have to do the development. So this is the very important point you should never miss. So draw the development. So the true length of this slant edge OE, I am getting 79 mm. Using 79, right? Draw the development. Draw an arc. Draw a simple arc, right? A thin arc only. Don't draw any thick arc, right? So now you know this is 40 mm side. So from here you cut an arc, right, at 40 mm. From here again you cut a arc at 40 mm. Similarly you cut at 5 places, you will get a complete development. Now join this with thin line, don't draw any thick line. So this is only thin lines, and name them A B C D E, right? A B C D E, and this is your again A, right? The starting point and ending point will be the same point. So in between don't draw any thick lines, because we need to draw only thick lines for the lower portion, right? Lower portion. So now this is 1, right? 1 should be projected onto true length line. So that one is on OA, right? On OA line mark 1. So measure either from apex to 1 or from here to here, that is the C to 1, right? Anyway you can measure and mark it appropriately, right? And this is 1, and similarly 2 should be projected onto this line, and 2 should be measured along the 79 mm line, right? So 2 here you are obtaining, and 3 similarly 3 is no problem, 3 is on OC itself. So 3 should be measured on OC line and mark here, and on OD you have 4, point number 4. So point number 4 also should be measured. So 2 and 4 are having the same length, right? Once you measure 2, you mark 4 also, right? You can save time. Similarly, once you measure 1, you mark 1 here, right? And OE also, right? So this is 5, 1 and 5 is at same distance, and 1 is here, right? Again 1 is here. So 1 distance if you measure, you can mark 3 points, right? 1 here, 5 here, and 1 again here, right? So that you can save time, right? So now you join this using straight lines, right? Don't draw any curved lines, right? Since it is pyramid, so 2 to 3 thick line, 3 to 4 thick line, 4 to 5 thick line, and this should be drawn with thick line. Now these edges, right, slant edges, whatever is remaining here, those should be drawn with thick line. So this portion should be left alone as thin lines. And now from 3 to C thick line, 4 to D thick line, 5 to E thick line, right? So this is the lateral surface development, right? So you have to do the retained portion development here. So you have to draw the base also. The base should be drawn like this, right? Base should be drawn like this, and this is the you can draw anywhere, right? So this pentagon can be drawn anywhere, right? No issues. and this is the point problem number 8. Next, problem number 9, it is a right circular cone, right? A right circular cone of base diameter 60 mm and height 70 mm is resting on its base on the ground. It is cut by a plane inclined at 30 degrees to HP and perpendicular to VP, right? So that is the cutting plane position. The cutting plane bisects the axis of the cone, so it is exactly meeting at middle of the axis. Draw the development of lateral surface of truncated cone, right? Truncated cone we are obtaining here, right? You know the truncated meaning, right? Already we have discussed so many number of times, and one solid is obtained, that is known as frustum. When you cut the cone, when the cutting plane is parallel to HP, then you obtain a frustum, and when it is inclined, you obtain a truncated cone, right? So this is the lateral surface development we have to do here. So this is simple cone. So this is again, this cone I am dividing into 12 equal parts, and this is the cutting plane. Cutting plane is inclined at 30 degrees to HP and exactly meeting at midpoint of the axis. So similarly you mark the cutting points 1 2 3 4 5 6 7, and totally I get 12 points. So now the true slant, so this is my true length line, right? So I am getting 76 mm. So using 76 mm, you draw the line here, and another radial line can be drawn using that subtended angle theta, right? Subtended angle. So I am getting 142 degrees, right? 142.1. So I am making it a round figure, 142 mm, 142 degrees, right? So now you can at 142 degree you can draw another radial line. You can join this using thick arc, right? So directly you can draw thick arc, right? So this is 12 parts, right? Now you have to divide this into 12 equal parts, right? 12 equal parts. So this is A B C D E up to L, right? So divide this into 12 equal parts, and then you have to mark these points. So similarly here, this is only true length line, right? All the points should be measured along this true length line, right? You project draw a straight line onto this true length line, and at that distance you measure along true length line. Only that distance should be marked on corresponding line, right? On corresponding line. So now 1 is no problem, I can obtain 1 here. So this is 1. On other side also I can mark 1, right? 1. 2 is obtained on OB, right? OB. So 2 point you project onto true length line, measure along this true length line. That distance should be marked here, right? So similarly 3 4 5 6 7 8 9 10 11 12 and again 1, right? So now you have to draw a fine arc, right? So you have to draw arc, right? So it should be drawn carefully, right? Using French curves you will get a very fine curve, and don't draw thick lines for these lines. These are just imaginary generators. Don't draw thick lines for generators, right? So this is the lateral surface development of the cone of retained portion. So this is how you should develop a cone, right? When it is cut by a cutting plane, obviously it is a truncated cone. So problem number 11, a pentagonal prism of base height 25 mm and height 60 mm stands on one of its ends on the HP with a rectangular face parallel to the VP. A hole of diameter 30 mm is drilled centrally through the prism in such a way that the axis of the hole bisects the axis of the prism at right angles. So it is a hole problem, it is not a cutting plane problem, but it is again a very simple problem. The axis of the hole is perpendicular to VP. Draw the development of lateral surface of the prism. So it is again a very simple problem, right? Only remember, you have to measure and mark the true lengths, right? True lengths. So with that, if you keep that in mind, this problem is very very simple, right? Draw the cone. It is sorry, a pentagonal prism, right? It is drilled by, it is drilled here, right? It is drilled a drilled hole of diameter 30 mm, right? Now this is E is a edge which is invisible, D is an edge which is also invisible, right? So now you have to mark the cutting points. So this is the extreme point on left hand side. I have taken as 1, right? So cutting points. So this is 2, right? On E, right? It is E, point number 2, and this is the point number 3, and I am taking as 4, 5, 6, 7 and 8. So totally 8 points I am taking here, right? Wherever it is cutting the edges or surfaces, there I am cutting, I am taking 8 points, right? I am taking point, right? So this is one is passing through this surface, right? It is passing through this surface, whereas you have two surfaces, one is A to E and you have A to B, right? So this is one is passing through here. On my top view, right, I am marking these 2 points as N and M, right, for my reference. This one is projected here, and it is not cutting any edge, but it is passing through the surface. So I am marking 2 points here to measure the true length. So that is the purpose of these 2 points M and N, and remaining points no issues. So you have 2 is here, right? Similarly for 5 I am getting these 2 points S and R. So these two are the reference points to measure true length, right, in top view, right, from top view. So these two are the reference points, R, S and also M and N, right? And then you have a point. So this is point number 2, right? And I have this point should be marked here, and that I am naming it as P, point number, point P. Similarly here I am naming it as Q, right? So Q, these points are purely used to measure the true length, right? So these 1 2 3 4, these numerals can be obtained along these parallel lines, and this PQRS on the surfaces we are going to mark, right? On the surfaces we are going to mark, so it will be clear, right, while doing this development. And this is the A. I am opening from A, so this is A, and this is 125 mm, and this is 25 mm side, and there are 5 sides 125 mm. Now draw thin lines, only thin lines. B, C is not cut, right? C is not cut, so directly you can draw thick line. C is not cut, and C can be drawn thick line. And D is it is cut by hole, and it should be drawn thin line. And you have E also, E should be drawn with thin line, right? So if you open up, right, so this hole is observed in front surface as well as at the back surface. So back surface, it is ED, it is passing through ED, and on the surface through N and S. In front, it is passing through M and R, and it is cutting the edges at P and Q also, right? So those points we have to mark carefully. So I will tell you the procedure, right? So this is A to B, A to C, and you have C to A. So this is the A to C, right? A to C is the front surface, and from C to A is the back surface. C to A is back surface. So now this is done, right? These points are projected here like this, and now whatever points you get here, those can be marked, right? So this is the first point. From each and every point you draw the parallel lines, right? Thin lines only, don't draw any thick lines. So now you mark this, right? A towards B, you have M and P, and mark them. A towards B you mark M and P and draw thin lines, and C towards B you have R and Q. C towards B you have R and Q, you draw two more thin lines, and C towards D you have S, right? C towards D you measure C to S distance, and towards D you mark that distance and mark S and D, right? S and N, sorry, S and N. So once you get these lines, then almost your work is done, right? So you have to mark the points, and this is on M line. On M line you have 1, right? On M line you have 1, right? You have 1, and it is passing through this surface. So on P line, you have 2, right? It is passing through the front surface, and we are projecting now front side. It is the front side. So point 2 is on P line, right? Point 2 is on P line. So that's why I have taken these two reference lines, right? So that I can mark 1 and 2 easily, right? So now I have 3, there is no problem, it is lying on B line itself, right? So this is point number 3, and 4 is on, right? 4 is on Q line, right? On Q line I am marking 4, and on R line I am marking 5, right? On R line I am marking 5. So similarly 6, 7 and 8. So all 8 points I have projected here, right, on front side. So on back side also I have to project all these points, right? So now this should be drawn, right? This should be drawn with properly, right? You have to draw using French curves. So draw the curve, right? Draw the curve. So now we will mark the other points, right? Other side, and you have 1 here on N, right? On N line you have 1, mark 1, right? And you have 2 is on E line, right? 2 is on E line. So 2 is on E line itself, so no problem, I have 2, right? So 3 is on the midline, right? So this is the midline. So this is the midpoint, right? In between E and D you draw a midline, right? So you bisect this D and E distance, you draw this line, you will get point number 3 on that line, right? So 4th point is here, so similarly 5 point is here, 6th point is here, 7th point you will get here, and the 8th point is here. So now you have obtained all the points. So front side 8 points, and back side you have 8 points. So using French curves, so you connect these points smoothly, and you project them, you draw them with utmost care, right? With utmost care. So using French curve it will be a fine curve. So now coming to this, right? Coming to this, you have a provision to use compass, right? So you see here E and D is a true length line which is parallel to VP, right? E and D, right? So ED line, right? ED points in between ED you can connect using compass, so that comfort you have here, right? Now take this as center, and this point to 7 as radius, right? Or you can take radius of 30 mm, right? So from here to here it is a through hole, right? So now this surface ED surface is parallel to VP, so you can draw using compass. So only here you can use compass. Now take this as center, 15 mm as radius, connect 6, 7 and 8, and also 4, 3, 2, right? These 3 points here and 3 points here can be connected using compass. So that comfort you have here, right? That comfort you have here. Now using that radius, the 15 mm you connect using compass. Now these points you connect, right? 4, 5, 6 very smoothly using French curves, right? Using French curves. So here you can connect, so that's why I have drawn this arrow mark, right? So where you can draw using compass, right? Using O as center, O6, that is 15 mm as radius. You connect using arc, right, using compass. You will get a very fine curve. Now we have completed all the points, right, all the points. The thick lines you have to draw carefully, and B line, right, it is a hole. So C to this upper surface, and 3 to this B point should be drawn with thick lines, whereas D from here to here thick line, from 6 to the upper surface 6 should be thick line, right, and draw thick lines. And this is your the development when a through hole is drilled, right. So this is the very simple problem, but you have to do it very carefully, right. So you have to draw the reference lines and reference points carefully. You have to measure them, and you have to mark in its corresponding development. Next is problem number 12. A square pyramid, right, of base side 35 mm and axis 60 mm rest on its base on the HP, with one of its sides of base inclined at 30 degrees to VP. A string is wound round the surfaces of the pyramid, starting from left extreme point on the base and ending at the same point, right. So it is a indirect problem. You have to mark the points from the string, right, from the development. You have to mark the points in simple front view. Find the shortest length of the string required. Also trace the path of the string in the front and top views. So it is another very important and interesting problem, where you have to proceed in reverse order, right. You have to proceed in reverse order. So this is the simple front view and top view, right. The orientation is very important. It is the one of its base edge is making 30 degrees to VP, right. Draw its simple front view. So here, to draw simple front view, none of the slant edges are parallel to VP. So I am turning this OA, right, parallel to VP, and then I am projecting here, right. So the height is given, but true slant length should be find out, right. So with the height given 60 mm, and I am getting true slant length is 65 mm, right. So using that 65 mm, I am going to draw the radial line development here. So 65 mm, and one side is 25 mm, 35 mm, and draw the arcs here and complete the simple development, right, simple development. So this is the simple development. And now students, the shortest distance between two points is obviously a straight line, right. So from this corner to this corner you draw a straight line. It is nothing but the string. Now string is wound around the solid, right. So now in this order you have to connect it. So it is obviously, the shortest distance between 2 points is obviously a straight line. So A to A should be connected with a straight line, and now you can mark the points on each edge, right. Those points can be marked here. So it is a reverse process, but very simple problem. It is simpler than the cutting plane problems. So now mark the points. 1, it is 2, it is 3, it is 4, it is 1 again. So this is the simple development. Everything can be thick line, right. All edges can be drawn thick lines because there is no removed portion here, right. So 1, 2, 3, 4 and 1. So those points you have to project onto front view as well as top view. So on both views we have to trace the path, right. So on A, so this is A, right, you have 1, right, 1. So on OB, so you have OB, so this is OB, you have 2, point number 2, but you should never mark directly on this, right. So now measure this distance from O to 2 and on this true line. So this is the true line, right. So mark on this line. From there you project on to this line. right? So that way you should do it, right? So first mark here and then project onto this line, draw a parallel line, right? So now this is the point number 2. So 3 is on OC. Similarly, OC, none of the slant edges are true length lines, right? So for all points, you have to mark on this line, right? On this thin line, and from there you have to project onto corresponding line, right? So point number 3 is obtained like this, and point number 4 is obtained like this, right? So 1 2 3 4 and 1, right? So now draw the line, right? Now draw the thick line, 1 to 3, 3 to 4, 3 to 4 is not visible, so draw using dotted line, and 4 to 1 again a dotted line. So this is the path traced in front view. So we have to draw in top view also, right? In top view also. Now from each point you project onto the corresponding edges. So this is 1, right? This is 2, and this is 3, right? This is 3, and you have 4. All the points are obtained here. So 1 2 3 4 you connect with thick line, right? You connect with thick line. So this is the path traced in top view, right? So this is the path traced in front view, and this is the path traced in top view. So this is your the corresponding development for which the path is traced for the string which is wound around this solid, right? So a cone, right? A cone of base diameter 60 mm. So it is also a plane, right? It is cutting plane. It is cut by a plane perpendicular to both HP and VP, 10 mm away from its axis, right? So the cutting plane is actually passing through the solid, which is perpendicular to both HP and VP, right? Which is perpendicular to both HP and VP. So in top view also it is cutting the solid, right, 10 mm from its axis. So cutting plane is a vertical line, right? Cutting plane is a vertical line. So for which you need to draw the development. So this is a hand drawn diagram. So this is the cutting plane which is passing through perpendicular to the axis, perpendicular to both planes, right? The perpendicular to both the planes. Now for each and every edge, right, I have divided this into 12 equal parts. I have marked all the points, right, for each slant generator, and those points should be projected onto the development, right? So see, as usual, you calculate the R by L into 360, so that gives me 140 degrees, right? So that is projected here, and these are the cutting points, right? These are the cutting points you mark on the corresponding generators, and this retained portion should be drawn with thick lines. So that's all you have to do. So it is a kind of problem where the cutting plane is perpendicular to both HP and VP, right? So please try this, and it will be very interesting problem and also very simple problem. So you have only 6 cutting points, 7 cutting points. So using 7 cutting points you can obtain, because it is not cutting all the generators, it is cutting only one side generators. So you will get only 7 points. So those 7 points, if you project onto development, you will get the left portion development, right? So please try this problem. So here it is a type of problem where we have seen the hole which is drilled through the prism, whereas here we have a pyramid, right? So pyramid, it is also very similar to that prism problem. It is a drilled hole drilled problem, sorry. So it is a pyramid, right? This is the hexagonal pyramid, right? A hole is drilled, right? A hole is drilled through this solid, right? So this is the hole, right? This is the hole drilled through the solid, and now we have to mark the points as usual. We did there, right? And two slant lines you draw here to get the reference points. So now two slant edges, if you draw two slant lines, these are not actually edges, for getting the reference points, right? So here I am getting this is reference point, and I will mark it, I will name it S P R Q, right? So two slant lines, those will give me four reference points, right? Now these are the two slant edges it is passing through, right? So there is no issues, and we can mark them directly. Those points can be marked directly, but we have to measure the points from the true slant length. So this is the true slant line, from there only we have to measure. So this is point number 1, and this is point number 2, and this is point number 3, 4. On this reference line it is 5, 6, 7 and 8, right? So totally 8 points, and these 8 points we have to obtain on our other side. You have 8 more points, you mark them, right? So totally we are getting 16 points. So those 16 points we have to mark carefully, right? So now draw the, and this is the drilled hole, right? So it is hole passing through the solid, so that is shown with dotted line, and those points should be, similarly all the points on slant generators should be projected onto true length line. It is the true slant length, so that is 77 mm I am getting. So with that 77 mm you draw the arc, right? You draw the arc. So now it is not cutting D, that's why straight away I have drawn thick line, right? And A is also not cut by the hole, and I can draw the thick lines comfortably, right? So now this is my P, right? Point P on AB line, right? So A towards B you mark point P, and similarly you have the point, right, B towards C, right? B towards C it is a midline, right? It is a midline, right? B towards C it is a midline, and you have Q is here, C towards D, Q, and D towards E you have R, right? So E towards F you have a midline, E towards F midline, and you have S line, right? S line is here. So all the lines are drawn here, right, including slant edges, and I have to measure for all these points on the true slant length only. So my one is here, one point is here, so I have to project onto true slant length, and I have to mark 1. I have to measure the distance for point number 1 on true slant line, right? So measure it and mark 1 on OP line, and 2 is on B, 3 is on midline, so 4 is on C line, 5 is on Q line, and you have 6, 7, 8, right? So one side you are getting these points. Now there is no provision, right? You have no you cannot use the compass, right? But you have to connect these points using French curves. You have to connect them very carefully. On the other side you have 9, 10, 11, 12, 13, 14, 15, 16. On the other side you are getting similar points, right? So you please connect them using French curves very smoothly, right? So this is how you should connect them, and similarly this side you connect them, and draw the thick lines for these edges, right? C2 4 and 4 to O should be thick line, B2 to the A2 O should be thick line. Draw thick lines for the slant edges, right? So there ends your problem, right? That is problem number 15, a through hole drilled through this hexagonal pyramid. So coming to our last problem. So it is a combination of different solids, right? A funnel tapers from circular opening of diameter 70 mm to a circular opening of diameter 20 mm over an axial length of 50 mm and extends axially to a further distance of 40 mm. So there is a cylindrical portion of height 15 mm above the tapering portion. So the tapering portion is nothing but frustum of a cone, right? Frustum of a cone, and it is very simple object. Frustum of a cone, right? There is a cylindrical portion of height 15 mm above the tapering portion. So that is cylinder. So it is made up of cylinder, right? And the simple front view and top view is like this, right? So this is the top view and two circles, and this is one cylinder, this is one cylinder, and now you have a tapered portion, right? Tapered portion, and then you have another cylinder, right? So it is made up of two cylinders and one frustum of cone, right? So you have to draw this simple front view and top view carefully. So to get the slant length, right, of this cone, right, you project this up to this axis line, right? This side also you project up to axis line. Now measure this. I am getting 80 mm. So slant length is 80 mm. So you can easily measure the theta now, right? Theta r by, so r is the radius, r is 35 mm here, right? R by L, so L is 80 mm into 360, that gives me the subtended angle for this cone. And these two cylinders you can easily develop using parallel line method, right? Parallel line method. So I have divided into three pieces, A, B, C. A is a top cylinder and B is the tapered portion, C is my bottom cylinder. So three I am dividing, I have named them, right? So pi d I am getting 220 mm. So this is the first cylinder. So it is a simple rectangle only, so no need to divide into any equal parts. So that gives you the simple what you call rectangle, right? It is a rectangle. Now portion C, right, part C can be projected, right, using pi d. I am getting 63 mm, right? It is again a rectangle, right? So now this tapered portion is a cone, right? It is a frustum of cone. So I have to calculate the theta, subtended angle. So I am getting 158 degrees, right? 158 degrees. So using 80 mm, the slant length is 80 mm. So using 80 mm, I have drawn a theta, the theta two radial lines, and the angle between these two radial lines is 158 degrees, right? So this is simple development, and now I have to get this much, right? So measure this slant length. So from here to here, right, and cut the arc here, cut the arc here. So that should be thick arc. Now draw the thick line from here to here. So this is the removed portion, it is not existing, right? So draw thick lines, and this is your part number B, right? Part number B. And this is a combination of solid problem, again very simple problem, right? No need to divide or no need to mark any points. It is again a simple problem, you can easily attempt this problem, right? So there ends the development of surfaces. For more information you can refer this textbook, right? Always the best book is ND Butt. You can refer this book. Thank you students.